Hi, everyone. Happy Friday. Hope everybody's doing okay. Hi, Adam. Hi, Adam. I hope you're doing okay. Happy Friday. So I don't have anything particular planned for the meeting today, Adam. I'm just here to answer any questions that anybody might have about the lecture material or anything that we've done so far. So if there's anything I can help you with, let me know. How did you find the membrane material? Oh, actually, that's sorry, that's next week. How did you find the biochemistry material? Did you have any trouble with it? I don't know if you can hear me, Adam.
I'm sorry, I think
Hi. I was just saying, did you have any questions about the lecture material from this week, or how did you?
I actually didn't. I thought it was all pretty straightforward. I'm just going through my notes right now just to
Okay.
see if I have anything.
Okay, good.
I obviously on the homework didn't I guess the question I got wrong was about the urine question with cells mixed in.
Oh, that's
I
right.
thought it would still be a solution, but obviously it's a suspension. So
Yeah, that one's a lot of people miss that.
because the cells would.
Right.
Let me just turn these off.
Sure. Those terms are just, they're very technical in terms of, what specifically they mean. A lot of people use the word solution for basically anything that, any kind of molecules that are, dissolved into a fluid. But we have to be technical in our language in anatomy. So remember that the difference is there are sometimes cells present and large crystals and things like that that are not going to dissolve in the fluid, and they're going to settle out of the fluid. That's a suspension. It is possible, it is perfectly possible to get a urine sample that would technically be a solution, right? If it didn't have anything that could settle out of it, but it would be unusual. Most of the time, there's at least a few cells in a urine sample.
Okay.
And of course, a colloid is different because the molecules stay suspended in a colloid.
Okay.
Yeah, colloids are weird.
Yeah. Albumin. Okay. Yeah. Gelatins. Okay.
Yeah, gelatins. Yeah.
Yeah. Okay. Yeah. I don't really have a ton of questions. I guess I just wanted to see if you had any like major points maybe that we should view for our test out of this unit. Yes.
I think the biggest problem that students have with the material that we had this week is the biochemistry material. And I try to draw some things together for students so that even if they don't feel like they're, experts in biochemistry, that's okay. You don't need to be, but you need to have this basic sort of concept that there are some things that will behave the way they behave purely because of their chemistry. And so I always reiterate this idea that it all comes down to atoms and bonds and what
Okay.
atoms are participating in a bond. And if you see a polar molecule, or you're told that a molecule is polar, you should automatically think things like, that's hydrophilic. It likes to be with other polar things like water.
Yep. And it's
And
solid. So,
and think hydrogen bonds,
okay.
hydrogen bonding. And then if you're told that something is nonpolar, or you know something to be nonpolar, you should be thinking that thing is hydrophobic. It doesn't want to be with water, and van der Waals interactions. And if you can keep those things straight in your head,
Yeah.
you're actually 80% of the way there.
Okay.
Yeah. And we have to have an understanding of that, just so we can explain physiology sometimes, and explain why things happen the way they do.
Okay. That makes sense.
But yeah, that's probably what students struggle with the most in this unit, is covalent bonding, polarity. It's tough. It's a tough concept. It's not something you can see or touch. So
Yeah. Okay. Okay. Well, I just more wanted to just drop in and I guess.
yeah,
based
that's
on-
what, well, and that's what these are for. That's what I'm planning these to be for. It's just a little opportunity to drop in. And periodically, if there is a concept I want to review, I'll do that as well. But yeah, absolutely. It's a drop in, ask a question, drop back out. Yeah. Okay.
Yep. Great. Thank you so much.
You're welcome.
Yeah. Bye.
See you next time. Bye. So as I was saying to Adam a minute ago, these Friday meetings are absolutely intended to be very informal. You can come on by, you can drop in, ask a question. If you just want to sit and listen to questions that other people are asking, that's fine too. It's just an opportunity for us to be in person with each other. What I like to do just to finish up today is I just wanted to take a look at the quiz. Most of you have handed it in on time. Very good. Thank you very much. It's important that you do these quizzes on time, because it will help you stay up with the material. What I hate to see is students who get behind. They forget to take the quiz, they forget to submit the quiz, and then they're struggling to get that done and watch the next lecture they're supposed to be watching, and so on and so on. The key way that you're successful in a class like this is to stay on schedule. So remember, your quizzes are going to be due on Thursday nights by midnight, unless you have an exam that week. If you have an exam earlier in the week, and you have a new lecture to do after the exam, I'm going to push the quiz to Saturday. But otherwise, it's due on Thursdays. So that's something you can expect every week. I'm going to go ahead and pull up the quiz. And we're going to talk, I'm just going to talk through a couple of key points. That's not quite what I wanted to bring up. Hold on just a sec. Bear with me. Nope, still can't do it. Hold on just a sec. See if this works. Nope. Okay, well, I'll have to do it this way. I'm just going to go into our modules here. I'm going to click where it says lecture homework, biochemistry and cell structure. And as the instructor, I have this added advantage of this thing called preview. And what that's going to do is it's going to pull up the quiz and it's going to show me what answers students should have provided on the quiz. So everybody did pretty well on this first question about atomic weight or atomic number. That one I'm not particularly worried about. Question 2, everybody's done pretty well on. I just wanted to pull question 3 up just to review an important point here. So polar molecules, remember, contain partial charges, and partial charges form when a covalent bond forms 2 atoms that have different electronegativities. So the question asks you to look at the following molecules and predict which ones you expect to be polar, essentially, which ones you expect to contain partial charges. And as a hint, I said to you, where might you find any of these polar covalent bonds? Notice that I'm asking you to predict or expect, because I'm not giving you the structure of the molecule. I'm giving you its formula. So you're making a prediction based upon the formula that you're looking at. Remember, we have 4 key elements. We have oxygen, nitrogen, carbon, and hydrogen. Oxygen has the highest electronegativity. Then comes nitrogen. Then comes both carbon and hydrogen. We consider carbon and hydrogen to have the same electronegativity, and it's low. So how can I use that information? Well, anytime I mix 2 atoms, if I covalently bond 2 atoms together that have different electronegativities, I expect to find partial charges. The atom that has the higher electronegativity is going to pull the electrons closer to it and farther away from that other atom. So any molecule that could potentially have an oxygen to nitrogen bond, an oxygen to carbon, or an oxygen to hydrogen bond would be a polar covalent bond. That would be a polar molecule. Nitrogen to carbon and nitrogen to hydrogen would also be a polar covalent bond. Different electronegativities in each one of these bonds. So the only bond that I haven't drawn for those 4, or I haven't included for those 4 elements, would be a carbon to hydrogen, a carbon to carbon, or a hydrogen to carbon. Those 2 atoms, those 2 elements, carbon and hydrogen, have the same electronegativity. So they would not, that would not be a polar covalent bond. That would be a non-polar covalent bond. So your hint is, where might you find any of these polar covalent bonds? Because that's where partial charges are going to be. So let's look. Water we know is polar. So hopefully you all got that one right. Methane. Methane only contains carbon and hydrogen. So the only bonds that can be formed in this molecule are between carbon and hydrogen. Those are non-polar covalent bonds, because these 2 elements have the same electronegativity. This one has, this molecule, glucose, has carbon in it, hydrogen in it, and oxygen. Different electronegativities. Oxygen to either hydrogen or carbon would be a polar covalent bond. That should be in your list. Glycerol, again, carbon, hydrogen, oxygen. That should be in your list. Limonene or limonene, I'm not exactly sure how to pronounce that word. It only has carbon and hydrogen in it. That's a non-polar molecule. Those 2 elements have the same electronegativity. That should not be in your list. And finally, the raffinose contains, again, carbon, hydrogen, oxygen. Differing electronegativities between the oxygen and the hydrogen, and the oxygen and the carbon. I don't know how the raffinose is structured, and that's okay. I don't know how the raffinose is structured, and that's okay. Because as long as I know there's a possibility that there's a covalent bond in here between oxygen and carbon, or oxygen and hydrogen, I know I've got a polar molecule. Hi, Keisha. Good to see you. We're just having I'm having a very informal informal Friday afternoon meeting. So I was just talking about some stuff in the quiz, some questions in the quiz. So if you have any questions that you'd like to ask about this week's lecture material, feel free. You're certainly free to unmute yourself and ask, or you can type into the chat if you'd rather. That's what these meetings are here for people to drop in and ask questions. And I'm here to help if I can. So I'm going to just pick up where I left off. If you just want to listen, that's fine too. I'm just going over a couple of the quiz questions that I thought some students struggled with. Some students struggled with. A lot of people did just fine on the quiz. So if you want to just listen in, that's fine too. Okay, that's great. So I'm just going to pull that quiz up again on my screen. Hopefully that's what you're seeing now too. Most people got question 4 correct. This was a question about anions, and I recognize this might have been just a tiny bit confusing for some of you. I saw it on at least one quiz. Someone said that the only anion in this list is chloride, thinking that an anion is a single atom that has a negative charge on it. In actuality, an anion is a negatively charged atom or a negatively charged group of atoms. So the sulfate up here, that's also an anion. And the phosphate down here, that's also an anion. The key is the negative charge. It has to have a negative charge associated with it in order to be considered an anion. Question 5. Again, most people got question 5 correct, but a couple got it wrong. These terms for solutions, I don't want you to get too stressed out about this. It's something we teach in anatomy, but it's not particularly important clinically speaking. But there are different terms used for different kinds of combinations of molecules and fluids. So a solution is, again, where that molecule can actually dissolve into the fluid. It's very small, the molecule in terms of its molecular weight. If you were to shine a light through that solution, those dissolved molecules are not big enough to bend the light in any way. So a solution is what we commonly think of when we think of things dissolving into fluids. Where it gets confusing is the difference between a colloid and a suspension. In a suspension, there are some big things in the fluid. Think of it that way. There are some things like cells or big crystals that are not able to dissolve completely in the fluid. They're big enough so that if you shined a light through that, the light would bounce off of them. The light would bend when it hit them. Now, when it comes to urine, it's technically possible to have a urine sample that doesn't have any cells in it or any crystals in it. It's technically possible. And all of the things that would be in it would be small enough to dissolve. But it's not very common. In fact, I'm going to say it would be very uncommon. Anytime we collect urine from a patient that is clean catch, as we call it, where we allow the patient to actually urinate into a cup, you're going to get at least a few cells in there. And those cells obviously are too big to dissolve. They're going to be in the urine and they're going to settle out to the bottom. So even though you wouldn't see it with your eyes that the cells are in there, that the cells have settled out, they're in there, and that makes that urine sample a suspension. Colloids are the really weird ones. Colloids are mixtures where the molecules stay suspended throughout the liquid. They don't settle out. They're still big enough to bend light, but they don't settle out of the solution. And the good example for a colloid is something gelatinous. The things that are in the fluid actually stay suspended equally, evenly, all the way through the fluid. Colloids are strange, but we learn about them because there are some colloids that are used in medicine. All right, let me go back here and just go through a couple other questions. Most people got question 6 right. I won't spend any time on that. I did want to mention question 8. These two terms, I wish there was an easy way to keep them straight, chromatin and chromosome, but you really do just have to memorize this difference. A chromosome, maybe this helps. If you translate the word chromosome, it means colored body. The first person that looked at a dividing cell underneath a microscope saw a chromosome as a colored body because they had stained the cell, so it had a color, and it was so condensed and so folded up that it was visible with a light microscope. The only time you will see chromosomes, actual chromosomes, is when a cell is dividing. That's the only time they exist. It is the most folded, stacked, condensed, tight form of DNA that you can see in a cell. It's called a chromosome, and it only appears during cell division. All the rest of the time, the DNA is in a form called chromatin. So that was that question. I'm trying to think if there was another one. Oh, 11. 11's a good one. So if you look at the questions here, these questions are all about phospholipids and in the membrane. Most people got part A and part B correct. It was C and D that some people had trouble with. Part C, the head region of a phospholipid is composed of glycerol. This answer is just incomplete. It should be false because the head region is composed of a glycerol molecule and a phosphate group. Don't forget about the phosphate group. It's a critical part of that head region of a phospholipid. And then part D says the two tails on a phospholipid are composed of amino acids. This is also false. The acids part is probably what confused some people. The two tails are fatty acids, not amino acids. Remember this, amino acids are the building blocks of protein. Amino acids are what make up proteins. Fatty acids are the tails on phospholipids. As I said, most people did very well on the quiz. Most of the scores were 9 out of 10. So if that's where you were on your quiz, you should feel good. You're in a good spot. You're obviously doing well and picking up a lot of information from the lectures. If you're maybe down, I'll say it maybe 7 or 6 out of 10, you might want to change up a little bit about how you're working and taking notes from the lectures. You may not be picking up quite enough information from the lectures. You might want to add in a little more detail. But other than that, that's all I wanted to talk about this evening. Next week we have membrane permeability and membrane transport. That's the only lecture topic for the week. If you have any questions as you go through that lecture topic, as always, be sure to message me and we'll talk through it. And otherwise, I will be here again next Friday if you need anything. So stop in, check in, and I'll see you then. Okay. All right. Have a good weekend. Be careful. It's supposed to snow. We're supposed to get a terrible storm. So be careful. Take good care of yourself. And let me know if you need anything.